In this video, we are looking at forces and acceleration. This is Newton's second law of motion, and Newton's second law of motion is F equals ma. The resultant force, F, is equal to the mass times the acceleration. So the overall force acting on an object is equal to its mass times its acceleration. So the resultant force, the overall force, is equal to mass times acceleration. So if there's no overall force, if it's an equilibrium, there will be no acceleration. Acceleration will be zero. If there is an overall force, there will be an acceleration. Resultant force is mass times acceleration. And when we're looking at the force due to gravity, that's called weight. The weight of something is equal to mass times the acceleration due to gravity, which is g. And remember, g is 9.8 meters per second per second. So F equals ma is the rule we're going to be using. Find the acceleration when a particle of mass 20 kilograms is acted on by a resultant force of 15 newtons. So F equals ma, the resultant force is 15, and that's equal to mass, which is 20, times acceleration. So divide both sides by 20. 15 over 20 is the same as 3/4, or 0.75 meters per second squared. One for you to try. Give it a go. So again, we're finding the acceleration, and we've got the mass and the resultant force. So the resultant force is mass times acceleration. So 36 equals 12 times acceleration. Acceleration is 3 meters per second squared. Here's another question. Find the weight when a particle has a mass 12 kilograms. So W equals mg. It's just F equals ma, but just when we're looking at the force due to gravity. So the weight is 12 times acceleration, 12g newtons. One for you to try. So W is mg, the mass is 20, so it's 20g, and it's the force, it's the weight, it's measured in newtons. A particle of mass 4 kilograms is acted on by an upwards force of 50 newtons. Find the acceleration. So this time we've got two forces. We've got an upwards force of 50 newtons, and downwards we've got the weight, which is 4g. Weight is mass times gravity, 4g. So then we can use F equals ma. The resultant force is going to be the force up, take away the force down, the overall force acting on it. 50 minus 4g equals mass, which is 4 times acceleration. So the acceleration is going to be 50 minus 4g divided by 4. If we type it into the calculator, let's get 50 minus 4 times 9.8 over 4. We get 2.7. 2.7 meters per second squared. Remember, we wouldn't give it to more than two significant figures because we used a rounded value of g, 9.8. One for you to try. Give it a go. So this time we've got a particle of mass m kilograms. So it's m kilograms this time. The upwards force is 30 newtons. The downwards force is mass times gravity, which is going to be mg. The particle accelerates up at 2 meters per second squared. Find the value of m. So let's put it into F equals ma. The resultant force is 30, force is up, minus force is down, minus mg, and that's equal to mass times acceleration, which is m times 2, or 2m. We want to get m by itself, so 30 equals 2m plus mg. We can change g into 9.8, so it's 2m's plus 9.8 m's. 2 plus 9.8 is 11.8. So 30 equals 11.8 times m. So to get m by itself, we're going to divide by 11.8. And I get 2.5 to 2 significant figures. It's okay to give your answer to 3 significant figures, but you definitely cannot do more than that. 2.5 kilograms. We could have also given our answer in terms of g. So at this stage here, when I had 2m plus m plus g, I could have said 30 is equal to 2 plus g times m, factorize out the m, and then divide by 2 plus g. So 30 over 2 plus g. And that would have been in terms of g, kilograms. Another question, a particle of mass 5 kilograms is pulled along a rough horizontal plane by a horizontal force of 20 newtons. The frictional force opposing motion is 8 newtons. So let's draw this. We've got a particle. Let's draw it as a little box. It's 5 kilograms. It's getting pulled horizontally by a force of 20 newtons. There's a frictional force opposing the motion of 8 newtons. And it's not relevant to the question, but I'll just put in the weight and the normal reaction, which will be equal and opposite because it won't be moving up or down. So find the acceleration of the particle. So we're going to use F equals ma, and the resultant force is going to be 20 minus 8. 20 newtons take away 8 newtons, and that's equal to mass times acceleration, so 5a. So 12 equals 5a. A is 12 over 5, or 2.4 meters per second squared. Find the distance moved in the first 4 seconds. So now we've got the acceleration, we've now got a SUVAC question. So we're finding the displacement. We know the initial velocity was 0. We don't know the final velocity. We know the acceleration is 2.4 and the time is 4 seconds. So we need the formula linking SU, A and T. That's S equals UT plus half AT squared. So S equals 0 times 4, which is 0, plus half of 2.4 times 4 squared. So half of 2.4 times 4 squared is 19.2. So it's 19.2 meters. One question for you to try. See if you can give it a go. A particle of mass 4 kilograms. The mass is 4 kilograms, being pulled along a rough plane, so there is friction, it's rough. A horizontal force of 12 newtons. Frictional force opposing is 4 newtons. And then the weight is 4g, and the normal reaction will also be 4g because it's not going to move up or down. Find the acceleration of the particle. So again, F equals ma. the resultant force is 12 take away 4, which is 8 newtons, and that's equal to 4 times acceleration. Acceleration must be 2, and it's meters per second squared, meters per second per second. Find the velocity after 4 seconds. So time is 4, acceleration is 2, initially it was at rest, and we want to know the velocity. So the equation linking VU, A and T is V equals U plus AT. So it's 0 plus 2 times 4, so it's 8 meters per second.